Good day. My name is Makita Mashala, and today I'm going to take you through the National City Bank EDA and modeling, which was done in R. The agenda is to take you through the problem statement, the EDA, the modeling that was done, and actionable insights. In terms of the overview, the research and modeling team at National City Bank has been tasked with creating a customer propensity model for new product, specifically a line of credit against a household's used cars. Since companies generally have obstacles in acquiring potential customers to support business growth, the objective is to develop a model that will be able to identify the top 100 prospective customers. Data of existing customers is available, which was used to train and select a model that provides the highest accuracy. Understanding the data, the information that has provided includes administrative, operational data, socio-demographic, purchasing power, and credit worthiness. Looking at the EDA, statistical analysis, outliers, distribution, missing values was done. One of the outliers identified was that for the recent balance, which was replaced with the mean. In terms of the distribution of the age, most people are around the age of 30 to 35, which is the peak of the age. In terms of the call duration, it was found that the most call duration was at around 5 minutes. The distribution of acceptance of offer, there are more people that did not accept than those who accepted. The household gender is more or less the same for female and male. In terms of the last contact month, May was the highest and December was the lowest. In terms of the jobs, we see the most people are management, blue collar, or technician. Most people are married. And in terms of the household insurance, the distribution is the same, more or less the same. The car loan, most people do not have a car loan. I looked at the Spearman correlation and found that there was higher correlation between the days passed and previous attempts made. EDA was done and we found that the number of NA values was highest for the past outcome. However, applying V-treat later, when we did the modeling, we'll deal with the NA values. The models that were considered were supervised machine learning. Given that this is a classification problem with binary outcome of either accept or not accept the offer, the logistic regression, decision tree, random forest, and KNN methods were looked at. In terms of the process flowed, I joined the data, I did feature engineering, and then I split and trained the model. I did initial modeling with all the variables, and then I reviewed the initial results, and then I selected only the important variables, ran the model again, and then at the end, I updated with the features that were only applicable as per the prospect customer's information. I developed the final model, and then I selected the optimum one based on the accuracy. Feature engineering included additional features such as duration, age bins, interaction between different variables, such as the balance and credit worthiness, normalization of some of the numerical variables. The logistic regression model, it analyzes relationships based on binary dependent variable. Yes, no, it's S-shaped, and you look at the probability of outcome with a threshold specified, generally at 0.5. A decision tree represents a set of decisions for binary outcomes, in this case, accept an offer or decline an offer in terms of accepting of a job offer. And then it looks at a criteria as a decision node, and then the leaf node represents the final prediction. Random forest is a multiple of decision trees which are randomly selected from the original data. You combine the results, and then at the end you have your final outcome based on majority. K nearest neighbor basically looks at the nearest neighbor of a point, and then it categorizes into either of the classes. After doing all the model in R, I found that the forest random using the ranger method had the highest accuracy, with the random forest using the train having the highest area under the curve. This is the ROC curves. These are the variable that were found to be most important. For example, the duration, the age, last contact month, last contact day, for example. And this was done in order to get a parsimonious modeling, which you will be able to accomplish the desired level of explanation or prediction with as few predictors variable as possible. Afterwards, I re-evaluated the model to check the results, and indeed the forest ranger was still up at the top with an accuracy of 0.855. And here again, the modeling with the ROC curves. For the final model to test the prospective customers, I had to select less variables based on the variables that I had on the customer data set. And in terms of the accuracy, the forest train was the highest with 0.735 and AUC of 0.50. The ROC curve I showed here of the different models. In terms of the final confusion matrix, it found that 98 customers who accepted the offer were correctly predicted by the model. And in terms of the 28 customers who accepted were incorrectly predicted to not accept. A snapshot of the final prospective customers that were selected. In terms of the key insights and from the exploratory data analysis and evaluation of the model, it was found that the call duration is the most significant. And according to research, successful calls normally average around 75.5 minutes, and the median recorded during the duration of existing customers was found to be 5.8 minutes, which is slightly slower than the average recorded, which is good. In terms of the number of contacts, it was found that the means are both the same. However, then the customers who did not accept have higher outliers than those who accepted. Age and job management had the highest acceptance, followed by the technicians. And in terms of the age category, the age between 26 and 39 had the highest acceptance. In terms of the last contact month, May had the highest acceptance and December was the lowest. Previous attempts, it was found that highest acceptance occurred for customers who had no previous attempts. Thank you.